we need to load vulkan1.dll in order to get access to Vulkan functions. At this point, a lot of people would tell you include windows.h. I'm going to tell you don't do that. Windows.h brings in a whole bunch of crap that you don't want. And I would like to avoid that kind of bloat. So we're going to hone in on exactly what we want. And exactly what we want is two functions. One function to load the DLL, another function to grab a function pointer from that loaded DLL. The respective functions are load library A and get proc address. We only need those two functions. It makes absolutely no sense to just bring in windows.h when we only need two functions. Rather than bringing in windows.h, we are going to bring in something called libloader API.h. Let's do that now. Include libloader API.h. And we can make a comment. And that's a little bit tight. Yeah, that is a bit tight, but that should work. So libloader API.h. We're only using it for get proc address and load library A. And actually, let's swap that around. And the reason I'm swapping this around is because within the workflow, we're going to do this first, right? Because we got to load the DLL. And once we've loaded the DLL, then we need to get a certain function from that DLL. So you might be wondering, like, why this is called proc. Well, proc is shorthand for procedure. Procedure is just a synonym for function. That's what it is, right? You also might be wondering why load library has this A on it. That A stands for ASCII, which means the encoding of the string that you're passing to the load library function is going to be in ASCII format, which means 8-bit values that encode the letters A, Z, 0, 9, and some other miscellaneous symbols that are found on the keyboard, usually, and some non-printable characters or whatnot. That is not in conflict. The other one would be W, which is basically Unicode. Right? You got Unicode, you got ASCII. We're going to keep things as simple as possible, so we're just going to use load library A. You may have seen other tutorials that will do something like just use a function called load library. I will never do that, because there is no function called load library. Load library, if you include windows.h, load library is just a macro that resolves to either load library A or load library W, depending on if the macro Unicode is defined or not. I don't like to get fancy with my macros. Yes, I do use a lot of macros, but I try not to get clever with my macros. Now, clever in code is not a good thing. It is a pejorative. You don't want to get clever. You want to keep things simple. Because as simple as you think something is right now, 3 months later, it's going to be a hell of a lot more complicated when you don't remember all of the details, right? Because the context is no longer freshly loaded into your brain, right? So keep things dead simple, because dead simple will eventually just be mildly complex 3 months from now because of the change of perspective. Okay, so I've ranted for 5 minutes on load library API.h. Man, I gotta reevaluate how I'm doing these. But hopefully some of the explanation here is helpful. Let's continue. First of all, I've never actually used this directly. I wrote some very basic assembly code to get access to these functions to avoid Windows.h. However, for this tutorial, I thought that was way too intense, and it would make more sense to use a more pragmatic approach, and so this is my new approach. But let's make sure that that actually is a thing here. So right now I am in a terminal that is within our MCV project. I'm just going to do demo.sh and just make sure that that include is actually valid. So just a really hackish way to make sure that I'm including something that's valid. So like if I did something like this, right? Put a whole bunch of X's there, I made something that does not exist, and we tried this over again, we would get some type of error message, right? So do this. Right, exactly, right? So yeah, that there's no such file or directory, right? So I just want to make absolutely sure that I'm not spewing BS as we continue here. Down in our file macros section, we're going to need to make a define for DLL. And a DLL type is just going to be void, which is going to be kind of confusing. But it's like, how abstract do we want to be? I think that for readability, having this little DLL type that resolves to void, I think that's going to be helpful, so I'm going to make it. And then down here, we want to make sure also to undefine that, so, you know, it doesn't collide with other people's code bases. Let's create some macros for the different DLLs. Or actually not macros, but I guess this would be the data section, yeah. So we're going to create a little data section within our code base, right? So we got data and we got functions. Data always should come before functions because functions rely on data, but data does not rely on functions in the general dependency of things. So then we can create a section for DLLs, right? DLLs. I don't know how we want to do this. I'm going to do this. I'm going to create like a little section like this for DLLs. So create a little line hierarchy here, right? Thinner lines, because this section is a subsection of data. And then within here, we're going to do MCV. Actually, these are going to be lowercase because they shouldn't be directly used by somebody who is including this library. So they're going to be lowercase MCV, and it's going to be data. We could also namespace it as DLL. Do I care that much? Maybe, maybe not. I don't know. Sure, why not? DLL. And then I'm just going to call it I don't know. I could just call it Vulkan. DLL Vulkan. But I like to keep all my abbreviations to 3 letters, so let's just keep on being crazy. And this is going to be a DLL type, but it's going to be a DLL pointer, right? Because obviously we can't call something void. Void is not actually a valid type, but a void pointer is a valid type, right? So we can do DLL pointer, and this is the name of the DLL pointer, and we initialize it to 0, which basically means that this is an invalid address, right? So 0 is reserved for invalid addresses, so we have a way to signify that this doesn't point to anything meaningful. Now, if we really want to be super pedantic, we can do this. We can go DLL pointer 0 like that. Yeah, right? We can cast the 0 to a DLL pointer. However, 0 is kind of special, where 0 does not need a cast. Like a 0 of any type is is interchangeable. But we could do this to be super pedantic if we wanted to. What else? So we have the Vulkan DLL. Do we need anything else? Well, there are some other DLLs we're going to need. However, let's just get this working first and then worry about that later. Also, we're going to need some types. Well, let's just get the DLL loaded. Let's just get the DLL loaded. We'll worry about some of these other things later because this is already getting a bit long. So in our functions, we're going to create something that returns a DLL pointer. And I'm going to indent here, and I'm going to say, well, actually, if we want to, let's keep everything terse, but let's just add an extra space here on these so we can kind of keep everything lined up nicely. So it's a function, and we want a function that is a little, we want like a function that loads a DLL, right? Now, because we already know this is a function, we could be really terse, and we could just call it function DLL, and we just know that the DLL function is just a function that loads a DLL. We could be kind of super terse like that, and then if we need to be more specific, because we have some type of collision, we can be more specific later. But I like to be as terse as possible and just have an implication rather than write out really long-handed function names. So I'm just going to call it MCV function DLL, and that's just going to load a DLL. And we're going to need a character pointer, which is the name of the DLL, right? So this is the name of the DLL. Okay. And CHR is not defined yet, so this is going to be basically means an ASCII character. So let's go over here where we've been kind of declaring these things, and let's define CHR as const char, and then down here we'll undef CHR. Okay, so that looks good. Now let's use that load library command, right? So load library A, and we want to use the name, and we want to assign it to some type of output variable. So we could say, you know, DLL pointer DLL equals load library A with the name. So the language is case sensitive. I know I haven't really gone over that, but this DLL all capital is a different symbol than DLL all lowercase. So a lowercase a and a capital A, they are two completely different symbols. So I like to just keep it this way because it makes it really easy to be like, well, what is DLL? Well, it's obviously just a variable of DLL type. Before we exit, I want to make sure, I want a fail-fast mentality. So if we are not able to find this library, it will put a null into this DLL variable. So if DLL pointer 0 equals DLL, then we have an error. So I'm going to create I'll create an error macro right now, well after this, but error failed to load library. Actually, we'll call it load DLL. Okay. You might notice that I kind of wrote this maybe in a very backwards-ish way. This is called a Yoda expression. And what this prevents you from doing accidentally is doing one of these. So you notice that I use a double equals here rather than a single equals. So a single equals symbol in C code means assigning, right? So you take the result. So this function call here returns a result of a pointer to a DLL, right? It returns like the DLL. And then use this one equal sign to assign it to this variable here, right? That's one equal sign. One equal sign is for assignment, but when you have two equal signs stacked together, that's for comparison. So we're going to compare this to this. If we accidentally did something like this, this is completely invalid right here. However, if we write it in a more traditional English-sounding way where DLL equals this, then this is actually valid C code right here, but it's a mistake. So we write the code as a Yoda expression just to prevent ourselves from making an accidental assignment, right? So now if we accidentally turn this into assignment, the compiler will complain because this is a constant expression, and you cannot take this and assign it to this because it's a constant expression. It's not, because the left side is not a variable, right? You can assign things to variables, right? So this line, you can assign something to variable, but you cannot assign to a constant expression. So right now we have this little error macro. So let's go do that, and then we'll come back to this. Actually, no, let's finish this first. Return DLL. And then we'll go up to here, where we're making all our little file macros, and let's create, and we'll do lowercase mcv function err, and this does not exist yet, but let's create it. So it's going to be void. It is all lowercase because it's a private function. It's only going to be used by the implementer of the library, which is us right now. But anyone including this library does not need to know about this function. So it's a private function. And it's private. Once again, it's private on the honor system, right? Obviously, somebody using this library could still see it like in their IDE or access it if they wanted to, but they shouldn't, right? If they're going to make well-conforming code that conforms to the rules of this library, they will not be using any functions that are lowercase. So this error function is just going to take a message string, and I guess I didn't explain that, so let's kind of get into this. So this symbol right here, this star symbol, denotes what's known as a pointer. So it points to a memory address. We'll get more into pointers later, but for now, just think of this char pointer as a string, and a string just means a sequence of letters. So a char would be like a, like this is a char, right? And then a string would be like some word here, right? So this is a string, right? If you're familiar with other programming languages, you may have encountered the word string, right? Now, I don't know why they call it a string. I usually think of it as like, you know, like if you have a bracelet and you're like putting on a whole bunch of like lettered beads onto a string. That's how I think of a string. You're stringing together letters and stringing them into a word. That's how I think of it. Now, a string is really just an array of characters. And an array is just a densely packed sequential storage of the same data type over and over and over again, right? So a string is basically like, so when you're thinking about this in memory, it's just like there's a whole bunch of memory slots, and there's a S, and then there's another character, right? O, and then in the next memory slot we have an M, and then in the next memory slot we have the E, and then an underscore W, right? Dot, dot, dot. So this is an array, right? So an array of characters is basically a string, right? So When you're seeking through the memory, in each little memory slot, you have like the next letter that is the string, right? And when you have a char pointer like this, the char pointer always will point to the first memory address of that string of characters. I know I'm not doing the best explanation here, but let's just kind of keep on going and just writing valid code, right? Because the most important thing is that we have code that works. If you don't have code that works, it does not matter how much you understand the theory or how theoretically pure everything is. If it does not work, it does not matter. So we're going to try to be a little bit pragmatic here. So I apologize, I'm not the best teacher. So this error function, all we're going to do is we're going to printf the error message. So we'll just say like mcv ferr. We'll just like let it know where the error message is coming from. We'll use a %s, which is a format specifier for a string. And then as another parameter, we'll specify the message. And I didn't quite do that correctly, did I? No, that's good. So now if we have an error, it's going to say mcvf error, and then it's going to say whatever the message is that we specified for the function call. Then, because we're failing fast, we want to exit, and we'll just give it a, I don't know, how about 0xff, right? Let's give it the maximum exit status of 255. Exit, I believe, is in a different header than the header that has printf. I don't quite remember exactly what header that is. Let me look it up really quick. So let's just say exit header. I'm just typing exit header into... Actually, you know what? I have some snippets for this. If I just write include... So I make heavy use of AutoHotkey. So if I just do this, I probably have it. stdlib. Okay, stdlib. There we go. Maybe next time I'll remember. But yeah, for the exit function. Also, including flush might be good. Okay, so that's already in there. So I'm just going to go modify this a bit. And you might be wondering what this is all about, the flush. I'll get to that. I just realized this function right here needs a little bit more editing. Okay. So when we fail fast and we print the error message, before we halt execution, we want to make absolutely sure that that error message gets printed to the screen. And the standard output, right here, standard output, basically your console here, that output is buffered. And sometimes it does not print characters until enough characters have accumulated in the buffer. So it waits till like a critical mass of characters has been built up before it like spits them out and shows them on screen. And this flush here will say, I don't care if you have just one character in your buffer, show it to the screen. That's kind of what this flush means. So this right here is going to guarantee that we see the error message here before we just halt execution of the program. And that's kind of important because if we don't have this, then every once in a while the program's going to just terminate unexpectedly and we're not going to see an error message, and that would be kind of horrible to debug if we don't see any feedback, right? We need to make absolutely sure we have feedback. So this will help us. That looks good to me. Let's see where we're using this. So we're not going to use this directly. We're going to use this little shorthand macro because we're going to make copious use of this, so I don't feel like typing this all the time. And we're already using it in one place. We're using it right down here, failed to load DLL, and this is just our function that is going to load a DLL for us. And we return the DLL right here. That all looks good. I think that we need to do like one more step, and that step right here would be loading the DLLs. So let's go over here and let's call a function called, how about m. So I just realized that this function should probably be lowercase as well. mcv function DLL. Actually, I'm going to call it DLL get. And then I'm going to create another function here called DLL pointer mcv function DLL all. And it's going to take void. And this function right here is going to load all of the DLLs. And we'll call it from here, right? So we'll load all of the DLLs. So we're going to load all libraries, right? So DLL, by the way, stands for Dynamic Link Library, which is specific to Windows. In Linux, I believe they're called .so files. I don't know what the SO stands for. But yeah, so we'll load everything here. And right now, all we have is the Vulkan 1 that we want, right? So we're going to do mcv data DLL VUK for Vulkan. Really, I don't think I should be abbreviating it that way. It should be VUL, first 3 letters. Yeah, so I can see that. That's what I did there. And it's going to be equal to mcv function DLL get. And it's going to be Vulkan 1 dot DLL. And that looks good. That's all we need. Okay, yeah, let's give that a shot and see kind of like what we may have screwed up, because I may have screwed some stuff up. Looks good. Doesn't look like we screwed anything up. Excellent. So it's almost 30 minutes. I'd say we're good here. I'm going to commit this code, and then I'll be done. So let's just do... And this is video number 8. All right, we're done. I'll see you in the next one.